Good morning, friends. I'm Dewey, and my Tech Talk topic for today is EV batteries and charging systems, with emphasis on the charging systems. At this time, there are four major markets in the world for electric vehicles: North America, Japan, the European Union, and China, all of which have different electrical standards and use different plug-in connectors. EV charging is a complicated subject, and I'll do my best to bring some clarity to the topic and focus primarily on charging systems used in North America. John Bogna, writing at howtogeek.com, explained that the length of time needed to charge an EV depends on the type of charging system used, type 1, type 2, or type 3. And I can say that it does depend on more than that, but we'll get into that later. Between these three types of charging systems, there are at this time in the world four types of AC charging plugs and four types of DC charging plugs. And this doesn't include Tesla's proprietary connectors. Now, type 1 and type 2 chargers use AC electricity only, or common type. Type 3 chargers, on the other hand, primarily use DC power. However, sometimes AC electricity is used in combination with DC electricity to achieve even faster charging rates with Type 3. Regarding Tesla, their plugs are also built to accept AC and DC power and come with adapters for use with other charging networks. I'll tell you more about them later. Type 1 chargers are simply regular home AC wall outlets, like you all have, I believe, and may take roughly 20 hours for a 120-mile charge on an electric vehicle. This type of charger can also work well for overnight charges on the smaller battery packs found in some hybrid electric vehicles. Type 2 chargers are those found in most public charging stations. They deliver 240 volts of AC power and have a special type of plug-in connector called the J1772 that is the standard for all EVs sold in North America. Type 2 chargers may also be installed in home garages for convenience. Charging speeds depend on a number of factors, especially capacity of the local electric grid. Cost at Amazon is around $500 or $600, though local electric companies often offer huge rebates or install them for free. Type 3 chargers, also known as DCFC, which stands for DC Fast Charge Chargers, provide the quickest juice up of all and have special connecting plugs. There are three types of Type 3 chargers at this time. I know it's getting a little complicated into the weeds. Look at my background. Anyway, the first of the Type 3 chargers is the CCS, the Combined Charging System, also known as the Combo Charging System, that is used in North America. The CCS connector left below combines a J1772 AC connector with a simple DC plug into a single connector to deliver extra power up to 350 watts. The EU combo plug at the right below is the European Union variant that has two additional DC contacts, which, as I'm told, allows for even higher power DC fast charging. Second type of Type 3, CHAdeMO. It's used mostly in Japan, but is also available in North America. It's an abbreviation of Charge de Mou. Sounds like a French term. It's a name actually derived from a Japanese phrase that translates as, "How about a cup of tea?" referring to the time it would take to charge an EV. As of June 2018, CHAdeMO allows up to 400 kilowatt charging and aims ultimately to increase that to 900 kilowatts, which is humongous. The CHAdeMO plug is shown below at the left, along with the previously described CCS plug in the middle and the EU combo plug at the right. Third type, the Tesla connector. It's a Type 3 connector, and it works with both the company's Type 2 charging network and its Type 3 supercharger station. It's approved for use in all regions of the world except the European Union, and that only because of the voltage differences between North America, and Europe. This proprietary Tesla connector accepts all voltages, so there's no need to have another connector like those others shown previously. Tesla installs and maintains these DC fast chargers, which are called superchargers again, for the exclusive use of Tesla customers. Charging time varies for numerous reasons, but can be as little as a half hour or could be quite a bit longer, again, depending on how many are charging and the electric grid. Our son Steve is a scientist and the CEO of Aquahydrix of Louisville, Colorado. So what does this have to do with EV charging? Steve explains it this way. Aquahydrix is commercializing a clean sheet redesign of water electrolysis to create the ideal platform for producing green hydrogen at a massive scale. Green hydrogen is predicted to be vital for industrial sectors that can't be directly electrified, such as long-duration energy storage for the power grid, and in numerous other areas in the industry worldwide. It's a complicated sentence, but if you read it twice, you'll start to understand. Green hydrogen is defined as hydrogen produced by splitting water into its H2 and O2 components using renewable energy. In a net zero world, which most world governments have agreed to achieve by 2050, approximately 15 to 20% of all electricity produced will be used to power electrolyzers to make green hydrogen. Now, since solar and wind are now the least expensive methods of producing electricity, they will play the leading role for powering our grid and consequently for charging EVs. And I thank my son Steve for describing the mission of his corporation, which is doing very well. To understand why this is important, one needs to understand the huge impact on the local electric grid alone that simultaneous charging of a number of EVs would have using, for example, Type 3 quick chargers at 400 kilowatts each. Now, each 400 kilowatt charger draws 40,000 watts. That's 0.4 megawatts. That's the equivalent of powering 4,100 watt light bulbs. Make a pretty bright room, huh? 100 EVs charging would draw 40 million watts or 40 megawatts, which would have a noticeable burden on most local electric grids and also, for that matter, regional and national. Then consider 1,000 electric vehicles charging at once. It's a humongous amount of power draw. The exploding market for electric vehicles and the consequent need for charging them will most certainly change the world we live in today. Well, that's my Tech Talk story, and I'm sticking with it because my son Steve even approved of it. Well, thanks for watching. Stay safe. And if there's any blood left in the turnip, we'll see you again next week.